And we are live. Welcome for this live stream where we are going to code a crypto version of Onlyfans. Yes, the porn industry is in danger and we are going to save it together with code. Welcome here. If you are new on this channel, I'm Julian and I've been a blockchain developer since many years. And if you want to learn how you can get started in this industry, check out my free roadmap, eattheblogs.com/roadmap. It's going to give you everything you need to know, the full roadmap, what you need to learn, and how to get your first job in the industry. This is some really high quality training and this is entirely free. So really, you should register for it. The link is in the chat. All right, so I see we have a lot of activity today. So let me see who we have here. Kushik, Mr. J, who's saying cultural degeneration. Frolian, Jetalai, careful administrator. It's already made on Solana. Yes, but it's always more fun when we build it ourselves. All right, Mr. EMM, Joshibe, Eddie. Okay, amazing. Many people. So yeah, I was sure that this kind of app will attract a lot of people. So look, I know this is very controversial, OnlyFans. The thing is, I don't think, regardless of if you are pro or against OnlyFans, I don't think this should be up to payment processors to decide what kind of app is allowed to process payment or not. And so typically the adult entertainment industry has a lot of problem with payment processor, like they are getting canceled all the time. And so I think it should be up to consumer to decide what they want to buy or not banks. So yeah, I don't really care for OnlyFans, but I do care about the freedom of running a business. So I think that's why this is important. Anyway, and this is gonna be fun also. So if you are completely new to blockchain, this is fine because we're going to do a step-by-step coding tutorial. So if you have some basic skill of web development, you should be able to follow. All right. So let's get started. So first, let me show you what we're gonna have at the end. Okay, so a couple of screen. So here, this is the home page. So it's going to give you a link of all the different creator. Yeah. So this is how we're gonna call basically the people on this website. We'll call them creator. Okay. So each of them have identified by their name because that's a crypto version. And we're gonna have a link, and when we click on the link, we're gonna land on the page of each of these creators. So with some information about them, and also a couple of private posts that are only shown if you've paid for, if you've basically paid for them. And finally, there will be an admin panel to allow creator to modify their data. Yeah, so let's see how the real thing looks like. So this is the homepage of OnlyFans, and here this is the feed of a creator. So most people think it's just for adult content, but I mean in majority yes, but not only. Like this one, for example, were completely legit. So I didn't have time to style the app exactly like in OnlyFans, but if we have time at the end, maybe we can do some CSS. But this is not the most important. The CSS part, the styling, this is the easiest part. The hardest is to understand the architecture, how which data we put on blockchain, which data we put outside of blockchain, and how everything communicates. And that's really what we're going to do together today. So let me show you the architecture that we are going to use. So yeah, so we're gonna have a front end And so this is how the end user interact with our app. And then we're going to have a smart contract where we store the payment. So every time someone makes a payment for a creator, this is going to be through a smart contract. So no need to use something like Stripe or PayPal. They can censor you very easily. So that's really the big benefit of using blockchain in this case. And then we're also going to have a backend. So why do we need this? Isn't it 100% decentralized? Well, no, because as you may know, this is very expensive to store data on the blockchain. So we have to be really careful, especially everything like text or images. This is just not manageable. So the text and the images, we're going to store them in a database. And this database, basically between the database and the front end, there's going to be a backend. Okay, and so the backend is only going to show the private post to the front end if the user has paid this creator. And also another reason we have to put them in the database is that on the blockchain everything is public, so there is no way to hide it. If we upload some image, some text to a smart contract, it's just not possible to make it private. Everybody will have access to them, regardless of whether they paid or not. So yes, from the front end, we can hide it, but in reality, anybody can create an open source client and and still access it by doing their own coding. So yeah, this is the only safe version, but we would still going to benefit from some part of the app will still be decentralized, and you will understand this. And we will use something called signatures, which you may not know. So this is going to be interesting. So in terms of technology, what we're going to use today, so we're going to use JavaScript, all right? So, for the front end, this is really the standard. Then we are going to use React.js. To be specific, NextJS, which is really one of the most popular framework right now. What else we are going to use? So we are going to use a framework called a library called Ethers that will allow you to interact with the blockchain very easily. We are going to use the Solidity programming language to code our smart contract. That's the most popular programming language for smart contract. We are going to use the Ethereum blockchain because, once again, this is the most popular tech in the blockchain industry. And we're going to use HTML, CSS. We're going to use Bootstrap, which is a famous framework to quickly style your app when you're a lazy developer like us. And finally, we are going to use a framework called Foundry. So this is a framework for creating smart contract and creating tests. So I know that it looks a little bit intimidating, so many different tech, but don't worry, it's not going to be so complex. I'm going to show you how to integrate everything. Let me see what we have in the chat here. Matimu, hello from Kenya. Gyokan, chance to be live. Gyokan, question about RWA token. No, we're not going to do that today. Maybe another day. THX, hey Julian, why didn't you stream today? Yeah, sorry. Usually I stream on Thursday, Wednesday and Thursday, but yesterday I was just underwater, too much stuff to do. So yeah, next week should be back on Wednesday. Okay, so time to code. Are you guys excited? Yes. Okay, so let's get started in the terminal. So let's create a new Next.js project. So create Next app. So this is a utility that I've installed that allow you to create Next.js project very easily. create next app, and we're gonna call this crypto Onlyfans tutorial. All right. Create next app. Hey, well, wait a second. What's the matter with that? Create next app. I do have it. NPX. Sorry, I missed NPX. Okay, my bad. NPX create next app, and I think it's going to ask me what is your project name. Yeah, so my project name will be let me see. No. I think I have to do it that way. Crypto Onlyfans tutorial. Would you like to use TypeScript? Hell no. ESLint? No. Tailwind? No. SRC? Yes. AppRouter? Yes. No. All right, let's get going. So now let's step in. All right, first we're gonna install a couple of dependency. All right, so what do we need? We need Bootstrap. We need Ethers. What else do we need? Bootstrap, Ethers, and that's it. Okay, so now package.json, Bootstrap, Ether, next. Okay, everything is good. Now let's start the server. Okay, so npm run dev. Okay, you know what? Actually, let's start first. Let's do everything in VS Code. It's more tidy. Okay, so new VS Code here. Let's increase the font size. Right. Okay, let's open a terminal here. Okay, you guys can see this clearly. Okay, so npm run dev, that's to start the server. Localhost 3000. Okay, so let me see. Localhost 3000. All right, so this is the default boilerplate. So now let's do some cleaning here. So layout here. This is how you define the initial CSS. So let me see my cheat sheet. Okay, so first we're gonna import Bootstrap. Then here let's import our custom style.css. So let's call this style.css. Okay, let's remove everything here. Back to layout. Okay, so let's give some title here, crypto Onlyfans, and let's find a cool description. Access exclusive content from your favorite creator. Okay, this is removed. This is some just default styling of NextJS. All right, so now, yeah, this we can remove it. Page.module. Okay, page.css. So here we can pretty much remove everything. Okay, so let's start from 0. So export default async function home. Okay, our default component. And here I'm gonna have some default styling. Because I'm gonna cheat a little bit here, but it's a bit boring. So let's just go faster for the basic HTML. All right. So here we declare an outer main element with some bootstrap in it. So container text center to make everything centered. Then we define a row. Then here a couple a column and a header. Okay. And now let's see what we have. So now crypto only fine. Okay. So let's make this a little bit more stylish. So we can go into styles.css in header. Okay. Background color. And let's find the color of Onlyfans. So I have an extension here where I can pick some color from a page. So click here. Now the color is copied to my clipboard, so I can just go back here and paste it directly. Okay. And now let's make the color white for the font. Okay, so now it should be slightly better. Okay, great. So let me see what people say in the chat. Gilkan, wouldn't be Tailwind a better choice? My choice is always the better choice. Never question my choice, my friend. But this being said, yeah, Tailwind, I mean, it's a matter of personal preference. So, yeah. Yeah, I'm an old school guy. I've always been with Bootstrap. It's working for me, so why change? Okay, so now let's go back to the home page. So what we're gonna show here. Here, we would like to show is a list of different creators. And so for that, we are going to, let me see. We are going to define a state. Okay, so here, let's call this creators set creators use state. No, actually we're going to, let me see. Actually, no. We're going to make this a server component. Because in React, in Next.js, you have this concept of server components. Some components are rendered on the server and some other are rendered on the client. But here, basically what we're going to do is we're going to read from a JSON file. So in a production app, we will do it with a database. For example, you can use Supabase, which is very good. If you guys don't know Supabase, let me show you. Supabase.com. That's basically a hosted version of PostgreSQL. So, or in other words, it's a very simple way to run a database in production. So this is what I would recommend in a production app. But for this tutorial, we can make it a little bit easier by using just a JSON object. So for that, okay. So first of all, let's do a very simple version. So const creators, and now let's do some basic stuff like this. So address 0x something. Then we're gonna have a name. So hey. Then we're gonna have what else? Yeah, that's it. Okay. So Next, we're gonna read from this creator object, array, sorry, creators, map, okay, creator, in all right. So for each creator, we are going to, how are we going to do that? We're going to do it in a table. Okay. First of all, we need to make sure that there are some creators. So here we do creators in creators length in creators length superior to 0. Okay, and if that's the case, then we're going to render our table. Okay, actually, let's hold on for the iteration. We need to do some setup before. So now let's start our table. So here we use some class name from Bootstrap. Table border, just to give it some basic styling. And let's give it some header. And then let's give it the name of each column. So the address. What else? Name. And a link. All right, let me see the chat here. So Jira, what network are you going to deploy? I'm going to deploy it locally. I'm going to use a local development blockchain called Anvil. This is a tool that belongs to the suite of tool of Foundry, but it wouldn't be much more work to deploy it on a public testnet or on mainnet. JG, how do the women, or how should we say, content creator benefit? Well, it's very simple. They're just getting paid to give exclusive content. So by the way, it's on Onlyfans, even though it's a majority of women, but it's not only women. It can be anybody really. But yeah, it's a little bit like Patreon. People give you money and then you give them some exclusive content. But the benefit of using a crypto version of OnlyFans is that it's they wouldn't be so scared to be banned, because OnlyFans. So there are two. They can be banned at 2 levels, with OnlyFans at OnlyFans level. So they can decide to ban any creator they want just because they don't like them. And second, OnlyFans can get in trouble with payment processor at any time. You know, all those adult entertainment companies, they always walk on eggs, and oftentimes they have to switch from a payment processor to another one, and sometimes you can be some downtime. So with crypto, what's great is like we can skip this. It's gonna be, the uptime is gonna be 100% of the time. So now let's check what is inside the table. And it's now that we're going to iterate all the creators map, creator. All right, and now let's do each row. And now we're gonna do each field that we want to render. So first, the address of each creator. So that's your ID. And that's how you can make sure that nobody is faking a profile. So let's say you have the real profile, and then for one real profile, for the really famous one, it's possible that you have many copycats. But for example, in the Twitter of the the real creator, they can put their crypto address, and so you can check very easily with this that you are dealing with the real one. Okay, so then let's do the name, creator.name. And finally, let's do a link to the creator page. So for that, we're gonna have another URL, creators slash creator address. And let me see here. Yeah, let's close this curly brace, and let's close this A element, and we're gonna call this a link. Okay. So now, are we good or are we not good? Let me see. So we close the T body, we close the table, and here, so that's related to this. If we don't have any creator, we're just not going to output anything. Okay, so now we have some minimal creator array here, so we should see something. Okay, 0x. Hey, this being said, we have a little problem with our array here. So are we missing something? Because we should have some border here. I'm a perfectionist. So table bordered. Okay. Okay. I know. Here. Okay. Nah, that's better. Okay. So now I like to have some real data, because here it's just some minimal data, but let's do something a little bit better for the data. So let's create a JSON file that where we're going to put more data in it. So creator.json. And let me see if I've already prepared some data. So here. All right. Okay, so I've created a couple of addresses here. So each creator is indexed by its address, and we have so here the address field, the name, and a description. And maybe you could also have a URL that point to the profile pic, but I didn't have the time to do it. Okay, so here we have three creators, and we're going to read from this file. So how are we going to do this? So let's create a function for. So first of all, let's get the fs module of Node.js, because we're going to need it to read some file from our computer, from the file system. Now let's define a function called get creators. And let's read from the file system. And so we're gonna do src app creators.json, and we need to specify the format, so it's UTF-8. Okay, and so let's save this in a local variable. So this is gonna be an array, and then we're going to pass this into a JSON, because at this stage it's just gonna be some text, but we cannot manipulate text directly in JavaScript, so we need to pass it like this. Okay. All right, and now let's call this function. So or let's do let. Okay, let creators in. Now let's transform it into an array. So we can easily do this with object.values. And this is how you transform an object into an array. So now basically we're gonna have here first creator, an object here, second creator, etc. This is what we're gonna get. So now it's easy to iterate below. Okay, so let's try again. And okay, so now it's working. All right, so base thought say it's decentralized, solve the problem of payment denying. Exactly. And Oscar saying, and it's much more anonymous in every sense for user. You will not fear that a transaction to Onlyfans appear in your credit card account. Yeah, so that's really a big issue with Onlyfans. Like people are afraid that somehow it's going to show up on the credit card. So usually all this adult entertainment, they have some tricks. Like for example, someone told me that they went to like some strip club somewhere in Eastern Europe, and on their credit card, of course, they don't say strip club. They say some bullshit like the whatever restaurant, like some pizzeria, or this is a pizza or something like this. So they try to be careful, but sometimes it's always a little bit scary. And there was this scandal of this website Ashley, is it Ashley Madison or something like this. Basically, this is a website for married people to basically to cheat on their husband or wife. It's like dating for married people basically, and they have like tens of millions of users, and I think like it was something like last year, a couple of years ago, there was a big leak. Like someone managed to leak the database on the darknet, and now they were basically extorting a lot of people that are threatening them to leak the info to their partner. So yes, privacy of payment is very important. Okay, so now we have our homepage. So what do we need to do next? So next, we need to start to work on the creator page. So let's go in our code editor, and we're going to create a new folder. So let's call this creators, just creators. And we're gonna have a subfolder, basically with a bracket here, square bracket. So address. So I know it looks really weird, but that's how you do routing in Next.js. So this means that you're gonna have a route that is called /creators/ and here's going to be a dynamic parameter in your URL, which is what we want. So inside, let's create page.js. Okay. So let's get started here. Okay, export default creator. We're gonna extract the params here because we need to extract the address. Okay, then let's return some skeleton HTML. So first of all, let's take this part here. right? Okay. Okay, so next, what kind of data we want to show? Okay, so let's show the basic data of a creator. Hey, why is not happy here? Oh, no corresponding. Okay. Closing element. Okay, now it's fine. So now let's display the info of a creator. So if there is a creator, then what we're gonna do is, if there's no creator, we show nothing. Okay, so there's a creator. We're gonna use a list. Okay, let's use some bootstrap styling here. List group. Right. Now let's show the basic element. Class name. List group item. Okay. And let's show the address of each creator. Now, next thing, we're gonna show the name of a creator, description, okay. What else do we need? So now we need to load this data, this creator. So how can we do this? So for that, we are going to use we're gonna use a use effect. So use effect, that's a function of React that allow you to run some code when the component is loading. So let's use that. So for here, when you put what you have here, basically every data that you put in this this array, every time this change, what is inside is going to run again. But if you don't put anything, it's going to run only once when the component first load. So for that, we need to get the creator from somewhere. Okay, so we're gonna create a function called getCreator. Okay. And set creator. So we're gonna save the creator to the state of React. And so we need to create a state. Okay, so initially the state is undefined. So now we need to import a few things. So use state and use effect from React. Okay, next we need to make this a client component. So that's a NextJS thing. Basically, when you put use client, it means this component should render on the front end, which allow you to use a use effect, for example. Otherwise, you can't do it. NextJS won't let you do it. Next, here you can see that we have a problem with await because we need to wrap this function in an async function. So let's do this like this. Okay, so now we are good with this part, but we still need to get the creator to create the get creator function. So let's do this right away. Let's call this get creator. All right. And then we're going to use the fetch function to send an HTML request. And we're going to send it basically to our backend, because that's the backend that knows how to get this data. So we haven't defined these routes yet, but we'll do it after. So API/creators/ here the address. And let's define the headers. So we are accepting a JSON response. Okay. So now let's get the answer somewhere. And when we get this answer, we need to change it. We need to turn it into a JSON, and we just want basically the JSON payload. Yeah, this is all we need. And then we're gonna define a key inside called creator. Okay, so now we good, but since we haven't created this yet, let's just fake it for now. Okay, so let's take creators.json in here, for example. So I like to do it step by step like this, and just to see if everything is working already. Okay. So, oh, it should be an array. No. What I'm saying is it's a single. No, it's a single answer. It should be an object. Okay. So now if I click on, for example, the first one, that's why I'm not seeing anything. Okay. So return. Maybe because I use a wait here. Let me see. Oh, okay. No. I know. Here, I forgot to call init. Okay. So now let's try again. Okay, now we can see it. The address, the name, description. Okay, great. So we're making a little bit of progress. So next, I'd like to define this endpoint here that is going to give us the creator. So for that, we will define an API folder in our file system. And then let's call this creators. And inside slash between square bracket address. Okay. And now let's create a file called route.js. This is how you can do API route in Next.js. Okay, so next. first let's get the fs module because we're going to read from the file system once again. After, let's export our endpoint. So this is going to be a get endpoint. So it's going to produce first a request object, but we're not going to need anything for this request object. However, we're going to need the address, and this is in a second object and in a key called params. Okay. So now we're going to read the JSON file. So let's go back. We're going to do some copy pasting here. All right. Yeah, so same thing as before. We read creators.json, and after, so JSON pass creators to turn into a JSON. Yes. After, let's transform this into an array because I'd like to select just one entry, but it's easier if this is an array. Okay, and yeah, let's reassign the creators variable. Okay, so now we have creators in an array. That's easier. And now we want to select the first entry that matches a certain condition. So for that, you can use the find function of Node.js. And we want the creator address to match the params address. And then we get our creator. Okay, and then we respond this to the front end. Response.json. So let's give the creator and a status of 200, meaning that everything is right, everything is fine. Okay, so now let's go back to the front end, and now our endpoint is going to work. So let's remove that. Okay, so let's reload. And he said that he cannot find the endpoint. Okay, so creators. Okay, I think I know. Here, let's put a slash. Okay, now it's working. Amazing. Okay, let me see what we have in the chat here. So Florian, hey dude, cheers from Chiang Mai. Hey, I love Chiang Mai. It's a really cool place. Anik, totaling arc, cool project choice. Thanks. So now we have the creator in the front end. What is next? So don't worry guys, there will be a part of it which will be in the blockchain. So we'll do a smart contract and also do some testing with the smart contract and integrate this with the front end. So it's coming. Okay, so now we have the creator. Next, it's time to connect. Okay, so basically, we want to make sure that we want to make sure that the user is really the person to control his or her address, because after we're going to ask the backend to provide us some data, but the backend is going to identify us with our signature. So it's not exactly the same way you identify people compared to Web 2. For Web 3, you can use signatures. And I'm going to show you how to do this. So first of all, let's scroll down here. And below that, below creator, we're going to read a state signature. So if we have a signature already in the state, we don't show this. Otherwise, we're going to show a connect button. And when people click on this button, they will be prompted to sign something. So let's give it some bootstrap class here. Primary. Let's give it some spacing with the element above. And when we click on it, we're going to call a function called connect. Let's call this connect. Okay. So now we need to define this state. So let's do this. Okay. So now let's create the connect function. It's gonna be async because we're gonna do some await call. Now, in order for us to require this signature from the user, so we need to step back a little bit here and talk of Metamask. So Metamask, this is the most popular wallet in crypto. So wallet is basically the equivalent of a password manager. So in Web 2, we have things like LastPass, for example, different password manager. But in Web 3, we have a wallet where we don't store a password, but we store a private key. But that's the same function as a password. Basically, it's something that you should never give to anybody. But contrary to Web 2, this private key, it actually never leaves the wallet, and it doesn't even go to any centralized server. It just stays on your side. And so with this private key, you can do you can do two things. You can sign a transaction, which allow you to do certain actions like send some tokens, send some money, or do some other action on the blockchain. But you can also create some signature, which you can use to identify yourself or identify that you want to do some action. So it's, for example, it's as if I ask you to, let's say you want to do something. So you write a letter, say, hey, I want to give money to someone, etc. And then you put your signature and you give it to someone else, and someone recognizes your signature, and so they actually do what you are asking. And so that's the same idea with a signature. But really, two different things you can do with this wallet. Either you create a transaction, which is basically a signed data package in any transaction that can be processed by the blockchain, or you just create a signature that can be processed by anybody, not the blockchain, but any backend can process this. And this is what we're interested in. Okay, so I already have MetaMask on my desktop, so that's basically a Chrome extension. You go to the Google Chrome store, and you can install it. And after, you will see this little fox here, and you will have different accounts. So here, if I click here, I see different accounts, and each of these accounts has an associated private key. So it's not what you see here. The private key is secret. It never shows. Here, this is the address. So that is associated to the private key, but that's something that you can show anybody. That's basically like a bank account number here. Okay, so we're gonna get a signature for the user, and this signature is gonna depend on which account they have currently selected. So let's get back to our code, and we need to import Ethers. So I mentioned there is this library that you can use to communicate with the blockchain. So we're gonna need it. We already installed it before with npm install. Okay, so now we go in connect, and we going to connect to Metamask. So how can we do this? So we do new ethers browser provider. And be very careful if you check out the documentation of ethers. 1 or 2 years ago, they switched from v5 to v6, and v6 is a bit different. But often when you search the documentation by accident, you can stumble upon v5. So here, make sure you always check it's v6. I'm going to explain this line, don't worry. So here with the ethers library, we create a new browser provider object. And in this object, we give it window.ethereum. So window.ethereum, this is basically Metamask. When you load your when you load your front end and you have Metamask already installed, Metamask is going to be injected in window.ethereum. And so with the object we're going to get from this, we can interact with the blockchain through Metamask. So we call this a provider. And the next thing we're going to get is a signer. So a signer is an object to basically this also allows us to interact with the blockchain. So basically at this stage, when you just get a provider, that's just the beginning of the process. But at this stage, you are not able to actually send transaction yet. You need the user to allow your app to use MetaMask. So you're not signing anything at this time. You're just saying, okay, there is this app that want to use my MetaMask, so I allow this app to use it. And at this stage, the app, the only thing they can do is read your address. So for privacy reason, there is this extra step because we want to make sure that we only, if some app read our address, we need to explicitly allow them to do that. Otherwise, they can spy on us. So we get this signer object, and we're gonna save it in a state because we're gonna need it after. So we actually also need a new state here. And after that is the magic moment when we actually gonna get this signature. So we use the signer, and there is a method called sign message, and we're gonna ask it to sign a message. So what is in this message? It's not very important, but it just needs to be unique to your app. So for example, it could be, if we want to make it really simple, could be crypto Onlyfans. Okay. And after that, we're gonna get the signature. So at this point, the user will see a pop-up, and it will have to approve it. And after, we're gonna save the signature. Okay. And so already with this, you should see this in the front end. So let's reload that. Okay, what's the problem here? So there is a problem of in the HTML. Okay, so let's scroll down. Another problem here. We're gonna fix this. It's not a big deal. Okay, here, let's remove that. I think that was it. Okay, cannot access sign. Oh, okay, line 23. So should have been undefined here. Okay, so now we see the connect button. We click on connect, and then we can see this pop-up of MetaMask appearing. So signature request, and the message that you need to sign is crypto only fan. So here we click it on sign, and after nothing happened, but now we have the signature in the state, and with this we can use it to identify ourselves to the backend, because now when the backend will see this signature, he knows that we're really the owner of this address. So it's not another user that is trying to spoof our address and basically try to take advantage of us because we were already paid for a creator, and they also want to see the picture for free. Okay, so the next part, actually we're gonna need to switch to the blockchain part, because we want to see if next we need to check if we're a paid member or not. So for that, what we do is that we're gonna create a new Foundry project. So I told you that Foundry is this smart contract framework. So now we're gonna use it. All right, so let's go to the terminal and let's use the forge command. So once you have Foundry installed, you can use the forge command, and to start a new Foundry project, we use forge init, and then the name of our folder is going to be blockchain, and we're also going to give it a flag no git, because otherwise by default it tries to initialize a git repo, but since we are already in a git repo, because NextJS also creates a git repo, then Foundry is going to complain. So we want to disable this feature. Okay, so let's do this. And now let's check out the blockchain folder that was just created. So our smart contract is going to be in the SRC folder. Here in test, we're going to write a test, and in script, we're going to have a deployment script. So those are the most important folder. So I mentioned smart contract, but you may not know what it is. So smart contract, actually, let me go back to the schema here. Smart contract, this is what you see here. On this schema, this is a small program that is on the blockchain. This is really what makes your crypto application so special. This is actually what makes a crypto app. It's because if you don't have a smart contract, it's just a normal app. So in our case, we're gonna have the logic for payment in the smart contract. We could have tried to put more stuff. We could have tried to put the content, like the picture, etc. But had two problems. So first of all, it's super expensive to do this, and second, it's not possible to make it private. So it's actually not possible to put the content on the blockchain. But for the payment part, we can do it. So we are going to use a programming language called Solidity for that. So here we have some default smart contract created by Foundry, but we're just going to rename that. Okay, so here let's call this onlyfans.sol. So sol, this is the file extension for Solidity. All right, so let's remove all of that, and I want to use Solidity 0.8.25. So that's the latest version available with Foundry. Here, this line tells Solidity which version we want to use. So if by mistake we try to compile this smart contract with another version of Solidity, it's gonna produce an error. So Solidity is a compile language. It's not like JavaScript where it's interpreted dynamically. So there is an extra step basically. Okay, so let's do this. So let's create our smart contract. For that, we use the contract keyword, and then we give it a name. So usually we just give it the same name as the file, and then between curly braces, we're gonna have our contract. So everything inside those curly braces belong to the contract. Everything outside doesn't belong to the contract. So you can see this as an object. We're gonna have some data, and we're gonna have some function to modify this data. All right, are you guys still here in the chat? Yes, you still following? So let's create. We're gonna create a. Let me see. What is the first thing we need to do? We're gonna create a function called join. So that's how you join a new member, a new creator. Sorry. So we're gonna have a single lifetime payment. You just pay once, and you can access the content forever. That's more simple than if you wanted to do a subscription. You can also do a subscription mechanism on the blockchain, but for this tutorial, we're gonna keep it simple. Just do a lifetime payment. Okay, so here we're going to give an argument to this function. So the name of the variable is creator, but the type of this variable is address payable. So type address. So I told you that address, they are basically like a bank account number. This is what we see here. So in Metamask, I told you this is this thing we see 0x70, etc. This identify my account basically. But in Solidity, it actually split this type in two parts. So one part is just plain address, and the other part is address payable. Address payable is an address that can receive money. So if you don't put payable, you won't be able to send money to this address. All right. Nick M's and Julian, I would just change the name to Only Crypto or something. A friend of mine made a super basic tutorial and got a takedown notice. Interesting. Well, it's I should be okay, but thanks for the heads up. Are you thinking of making the post? Are you thinking to integrate NFT? I think you're asking. No, but yeah, this could be a good idea. No, but we won't have NFT. So here, let's see the join function, how to do that. So after that, we make it external. That means we can call it from outside of the blockchain. And payable, so meaning we can send money to this function. So here, this address payable, this is a type of variable, and here payable, this is a keyword attached to the function. So it's completely different. And after, we're gonna do a few checks. So first of all, let's check how much money we sent here. So with MSG value, that's a built-in value of Solidity, and you can check how much money was sent to the contract. And if it's below a fee, and basically a fee that actually we will define before. So here we can define what's called a state variable. State variable means this is a variable that will be stored long-term in the blockchain. And so let's make it constant public fee. Constant means that this will not change. So that's a little bit the equivalent of the const keyword in JavaScript. Once you've assigned this variable, you cannot assign it after. Public means that we can read this value from outside the blockchain. And the fee is going to be a fixed fee. So 0.0001 Ether. And so Solidity understands this notation. Okay, so if the money we send to join is below the fee, then basically we need to trigger an error. So we do this with the revert keyword. So it's going to throw an error, and every state change is going to be reverted. It's basically as if the transaction never happened, but you still have to pay for transaction fees. And we're going to create a custom error. So there are different ways to deal with error in Solidity, but the most modern way is to do it that way. So you create a custom error, you give it a name, payment too low. You can give it some parameters as well, but here it's just empty. And here payment to low. Okay. So that's our first check. Second check, we're going to make sure that we haven't paid already, because that's a lifetime fee. So we shouldn't be able to pay twice. So for that, we need to keep track of who paid already. So for this, we will use a mapping. So mapping, this is a key value store. That's the equivalent of what the JavaScript object. So, you know, when we have like key here, value in JavaScript, we can do this. So we can do the same in Solidity. Address, then we're gonna have an inner mapping. It's possible to do this with another address that's going to map to a Boolean value. So here, that's as if here, let's say you have the outer key, then inside is going to, you're gonna have the inner key, and this is going to map to true, and then maybe another key. This one will map to false, and then here you're gonna have another creator with another key that is going to map to false or true, etc. So with this, you can know for a certain creator if an address has already paid to the for the creator. So let's call this members, right? And after now, if we can check that the members for certain creator and a certain sender, we can make sure that this is true. And if this is true, that means they already paid. So now we're going to revert already member, and then we're gonna tell them you're already member of this creator. Now already member, and here we pass a field in our error. Okay. Okay, then what else do we need? We need another check. So first, we're going to send the money. So creator, and to send the money in Solidity, this is how we do it. We call the call function. Then we specify how much value we send. And after, between parentheses, this is if you call the function of a smart contract. You're going to specify this here, but in this case, we just send some value. There is no function call. Okay, and then we need to check if this transfer was successful, because it's possible for the recipient to reject it. So there is a Boolean value we're going to receive, and then another value, some data, some additional data that we won't need. If this is the Boolean value is false, we're going to revert. Okay, payment, because otherwise the money is going to be stuck in the smart contract, and this is not what, and the creator doesn't get it, so this is not what we want. Payment rejected, and here let's create an error. Okay. All right, so now our smart contract is complete. Let me show you the whole thing. So as you can see, it's not very big. It's just 24 lines of code. So in general, smart contracts are never big. The most complex one are a few hundred line of codes to 1,000 line of code is really the maximum. And actually, there is a hard limit because the code cannot be more than 24 kilobytes. But that's a good thing because we don't want too much complexity in smart contracts. We manipulate money, and the longest our smart contract, the more complex it is, the more likely it is to have security vulnerability, which means it's more likely that people will lose some money. So you want to keep it as simple as possible. Okay, let me see here. I think we are missing a parenthesis here. Okay, so now that we have this smart contract, the second thing we need to do is a test. So this is very, very important. I just mentioned that there are all those hacks in smart contract. And so you never want to just write a smart contract and not test it. Because after you deploy it, you cannot update it. So you need to make sure it's 100% right so that no hacker will come to hack it. And the functionality are like you wanted them. So we go in a test folder and we're going to write a test file. We call this only fan. Okay. Here, Solidity 25. So this is some boilerplate code created by Foundry, but I'm going to explain to you. So first we import a base test contract. And here this notation means that we're going to inherit from this test contract. So we're going to have some, basically some testing utilities. And our test itself is also going to be written in Solidity. So here we have this contract test to organize everything. And in this setup function, this is what is called before each test. So here you have your individual test increment, test fuzz, etc. And before each test, setup is called again. So you're gonna start from with this pattern here, you're going to start from a fresh state. All right, so let's write our contract only fan. Okay, so let's define a pointer to our contract. So the type here of our pointer is only fan, and only fan with a lowercase. Here's the actual variable. In the setup function, we deploy a new only fan contract, and then we refer to the variable defined here. Okay, let's remove that. And we're gonna do our first test. Okay. Okay, let me see. There's some question in the chat. Quizabox. Hey, if we enroll if two of your course DeFi and DApp 30, are they both up to date? No, they are not up to date. These courses are not available anymore. So right now, we only do a Solidity bootcamp. So if you're interested in that, I'm going to send to you the link for, let me see, the blocks bootcamp. Yeah. So next cohort is going to start July 1st. So in 1 month, basically, we're going to turn you into a Solidity Pro. So you can check out this link. Okay, back in the code. So first of all, we're going to check that we can join successfully. So let's rename this test here. Let's call this join successful. Right. So for that, how are we going to do that? Okay, so here actually we need to do something else before. We need to define a few variables. So we need to define the address of the creator. So we make it payable because it needs to be able to receive money. And to create a new address, we use this notation. So it's going to create a new address, and then we need to make it payable. So we're going to cast the address type into address payable. Okay, so now we have this address. We need another one for the member that is going to join. So another address. And after that, we need to give some money to the member because it needs some money to to pay the creator. So when we create those address, like I show you line 9 and 10, by default, they have no money. So how we give them money with the deal function, that's something that is provided by Foundry. That's a testing utility. And we're gonna send it 1 Ether is gonna be enough. And after, we're going to configure Foundry to send all the transaction from this member. So for that, we do VM start prank. That's another utility function. So from now on, all the transaction after that will be sent from this guy. Okay, so first transaction that we're going to send is onlyfans.join, and here for the value, we're going to send the fee that is needed, and the argument to the join function is the creator, because you remember in our smart contract here there is an argument, so we need to pass this in our test. Okay, and once you've done that, then we're gonna check that everything works fine. So let's check that the member is actually a member. So Onlyfans, and now we call the members function. So I'm going to explain, because we don't have a members function. So how comes this work? Pass the creator and the member. So what we have is a mapping here called member, and this is a mapping with an inner mapping. So we have an outer address, an inner address, and then this Boolean value. But when you define a public variable, actually it's going to create a getter function of the same name. So here we actually have a function called members, and it's going to have 2 parameters, an address for the outer key and another address for the inner key. Okay, so the first one is the creator, the second one is the member. Okay, so this is why we can do this in this test line 20. So we're going to get a Boolean value that tells us if we are a member or not, but that should be the case because we've paid here. So let me see, did I? Oh no, actually I missed something. Sorry about this, I missed something. So below this, we need to update our mapping. So this is how we do it. Creators, then MSG sender. MSG sender, that's another built-in variable to tell you who sent the transaction. And we set it to true. Okay, so now we're good. So let's go back to test, and now we're gonna try the second, let me see. We're gonna try another address to see that it's not a member. So let's define this other address here, not member. Okay, and now we need to do some assertion. So assertion, this is a test that you do, and if this test doesn't work, it's going to the test is going to fail basically. Okay, so here is member 1 true, is member 2 true, and what else? And no, so sorry, the second one should be false actually. And finally, we need to check that the balance of the creator is equal to the fee that we just sent. Okay. So now should be okay. So we should be able to run the test already. So we go in the blockchain folder and we forge test, and we reference, first of all, we need to use match pass, and then we reference the pass to the test. Okay, let's run this. So we have a problem in our smart contract line 23 because that's not creators with the S, but that's singular. Okay, that should fix it. So now we have problem in our test. Fee is not defined. Let me see. So we forgot this. Okay, no problem. So here we define it. Fee equals 0. Okay, I don't want to make a mistake. So let's just copy paste this. Okay, so now it should be fine. Let's run again. And now everything worked. Okay, awesome. So our first test is working, but we still have some other tests, because what we tested is just the happy pass, but we also want to test the unhappy pass. So what if we trigger some of the error? So we have 3 error possible. One here, second one here, and a third one here. So we need to test each of these. So here, let's do this. Test join payment too low. That's the name of the error. Okay. So how this is going to work? So we know we are expecting an error. So we need to tell Foundry that we're expecting an error, and we do this by with expect revert, and we need to mention the error. So onlyfan.payment too low, and here dot selector. So the selector is basically an hexadecimal number, so something like this that will identify the error. Okay, so now we actually call join, and this time on purpose we are not going to pay enough, so fee -1, and after that we're also going to make sure that we are not a member, so Onlyfans member creator member. Okay, and let's make an assertion: is member false. Okay, so 2 things we're going to test here: that the error is triggered and that we are not a member. Okay, so let's try to run this, and now we have 2 tests passing. Okay, amazing. So next we need to test if we are already a member. So join already member. Okay, and what else? So Onlyfans dot join. So now we actually, let's copy paste from above here. So we join. Okay, first time, so no problem. And then we're going to join again, but of course the second time it's going to fail. So we're going to expect an error here, expect revert. And now what do we expect? So it's only fan dot payment rejected dot selector. Okay, and we try to join again. Oh no, it's not payment rejected, sorry. Already member. Already member. And here we're also going to specify that the value in the error, because this error has a field, so it's slightly more complex. And actually when you have a field, you cannot do this directly. So what you have to wrap this in abi.encode with selector. So basically it's going to encode all of this in a format that expect revert is going to understand. Okay, and then let's run the test again. Okay, so now it's passing, amazing. Okay, now we're gonna do the last test. So let's make sure that the payment is rejected. If the payment is rejected, basically the whole transaction should fail. But for that, first we need to create a what we will call a bad creator. So basically, this is going to be a smart contract that has nothing inside. And if you have a smart contract like this, basically it's impossible to send it money. So if you want to send money to a smart contract without targeting any function, you either need to have a receive function or a fallback function. But if you have nothing and you send Ether directly, basically it's going to reject it. So now let's deploy this bad creator. And after we're going to expect a revert. So the error is going to be Onlyfans payment rejected dot selector. And finally, we're going to try to join like this. Onlyfans join, but here it's not going to be the creator. It's going to be the bad creator. So first of all, we need to transform it into an address, because here is the line 47. This is a pointer to a smart contract. So to transform this into an address, we use this operator, the address operator, and then we need to make it an address payable. So we need to cast it a second time, like this. Okay. All right, so now let's try to run the test again and see how this is working. Okay, so now all our tests are passing, so that's amazing. So next, what we need to do is we need to deploy our smart contract to a local development blockchain so that we can integrate it with the front end. So for the deployment script, we're going to write it in the script folder. So let's rename that. Okay, so onlyfans.script.sol. Okay. So here we have some boilerplates we're going to modify. And so let me see here. First of all, let's import Onlyfans smart contract. From in src onlyfans.sol. Okay. Here this is gonna be Onlyfans script. Okay. Then here first we are going to get a private key. So we're gonna choose from which address we're going to deploy it, and we're gonna pick a very specific address where we already have some money inside. I'm gonna explain you why we have this address. So deploy a private key vm.env So here is going to read from a .env file that we have. It's going to read the private key from it. So you have to be careful if this is in production here. Here, this is just development, so I'm not going to use a real address with real money. But and after start broadcast, so we're going to indicate from which address we're going to deployer private key. Okay. And after, we're going to do new Onlyfans, and this is how you deploy it. Okay, so next, which private key are we going to choose? So for that, I'm going to show you something. So we're going to open a new terminal. Okay. And we are going to run envol. So envol, it's automatically installed when you install Foundry already. So let's run this. And envol, basically, this is a local development blockchain. So it's going to run a local Ethereum network, but that is just on your computer. So this is not real money inside. This is fake money. Everything that happened on this network has no impact whatsoever on the mainnet, which is the real Ethereum network. So you can make any mistake that you want. You can restart it. For example, here I can close it. I can restart it again, and the new version is completely independent from the previous one. And it's going to give you couple of 10 addresses that you see here, those addresses, and each of them is pre-funded with a lot of ether, and that's great because you can use these addresses to run tests, try things, make mistake, it doesn't matter. And you also have private keys. So here what I'm going to do is basically I'm going to select here a private key for the first address, so 0xf39 something, and I'm gonna create a .m file at the root of my, let me see, I think it needs to be at the root of the blockchain folder. Okay, new file, .m file. Oops, let me rename that. Put a comma, should be a dot. Okay, and after we're going to define a key, private key. Okay, we give it a private key. So let's make sure that you don't give the address, but we need the private key here. So 0xac something. Okay, and so now in our script we're going to read from this private key and deploy from it. And since this will be done on envol, we already going to have ether inside. Okay, so next we need to run our deployment script. So how are we going to do that? Okay, so we're going to do that with this command. So let me copy paste it. Okay, so forge script. So this is how you run a script in Foundry. Then you specify the path to the script, then which script exactly, because you can have several scripts in each script. Here, this Onlyfans script. Then fork URL. So you need to point to a specific blockchain. So here, localhost 8545, that's the URL of envol, and you can see it here, lessening on basically 127.0.0.1 is like localhost, and then the port 8545. And then broadcast. So broadcast means that you want to actually send the transaction. So I know it sounds weird to say that, but by default, Foundry is not going to send it. It's just going to do a test and not actually deploy anything. So here we want to actually deploy something. So -- broadcast. Okay, so seems fine with me. So let's press enter. And here the contract address is this. Okay, contract address block 1. You see how much ether you paid for the transaction fee. It was complete. And here you have some information about this transaction that was saved in a JSON file if you forget. And if you check out here on envol, the log of envol, you can see some details. So here you can see ETH send raw transaction hash. So this identify the transaction. You can see the address of the contract created. So yeah, that's real. It actually worked. So that's awesome. So now that we have this deployment, we can go back to the front end and we'll be able to interact with it. But first, let's create a JSON file with the information about our smart contract. So for that, we're going to do a new file. Let's call this contract.json. And we're going to have two entry. First, the address. Okay, and this second entry will be what we call ABI. So ABI, this is an array, a JSON array that is going to describe the interface of the smart contract, and that's useful because on the front end with this array we can know how we can call this smart contract. Basically, we know the name of the different function, we know the type of the parameter, etc. So let's go in, let me see, I think this is in the out folder. So the out folder is created by Foundry when you deploy the whenever you compile the smart contract. So every time we run the test, we did a compilation. And when we deployed it, we also did a compilation. And here you can see where is it in onlyfans.sol. So that's actually a folder. And here you can see the ABI with other things. So it's not really easy to understand it like this. So what we're going to do is we're going to a JSON formatter. You can find a lot available. You just copy paste your JSON, you click on process, and it's going to show you your JSON in a nicer way. So here we're going to select all the array. Let me see. And we're going to stop just before bytecode because after we have other information that we don't need. Well, let's go back here. And let's go back to contract.json, and here in ABI, let's paste this. Okay, so am I missing something here? Let me see. No. I think. Okay, no, I think that is. That seems I did a bad selection. Okay, let me do it again. So okay, let's try again. Seems it's right now. Okay, so we have our array, and here you can see the different functions. So here, for example, we have the fee function. With the what we have in output, what we have in input, the join function, so you can see the name of the different variable, the type, etc. And now we have enough information to interact with the smart contract. So we go back to the page of the creator. Okay. All right. Let me take a quick pause here. So we've done a lot already. It's been almost 2 hours, but you guys are still here. Amazing. Are you guys learning something? Yes. I see Epic Unreal in the chat. He's still here. Congrats, man. That's great. Danche Gaming seems easier to just import the out contract and initialize. Yeah, so except that there is still this a little problem. Can you do this? Because basically NextJS doesn't allow you to import something outside of its folder. So here, this is at this. Yeah, we should be able to do it. Yes, but that's just a habit. I like to have this JSON file, but you're right. It's easier to just import it. Okay. So next we are going to go back to the creator page and go back to the connect function. And now once we have the signature, next thing we want to know is if we're a paid member or not. Okay, so, and for that, we're going to need to interact with the contract. So how we do this? We use ethers once again, ethers.contract. And here we're going to need a few things, the address, the ABI. So let's import that. Import contract JSON from, let me see. Contract.json. All right, so now let's go back to a function. Here, contract JSON dot address, contract JSON dot ABI, and the last thing we need is the signer. So basically, this is our connection to Metamask. And let's get this object. Let's name it just contract. And after that, we're going to call the members function contract.members creator address, signer address. Okay, and so here we're going to call it, the members function, and it's going to give us a Boolean value, are you a member or not? And after, we're going to save this in the state set is paid member. Okay, so let's define this state. So is paid member, set is paid member, use state of undefined. Okay, and so what do we do with this? So if we are not a member, we are going to propose to the user to become a member. So how we do this? So just below the signature, basically we're going to do, let's check, we need to have a signature, and we are not a paid member. So if that's the case, then what do we do? So let's say become a paid member to unlock exclusive content, and then some more information. With a single payment of 0.0001 is, you will have a lifetime access. Yeah, that's it. Now let's do a button. Okay. Primary. And now when we click on this button, we're going to execute a join function. Okay, and we need to define this function. So let's go up, and just below connect, let's do this. So first of all, let's get let's get a pointer to our contract here. And we're going to execute the join function. So we need a try catch here because maybe it's going to fail. How we do this? So first contract join, and we need to pass first the creator address, and we also need to pass to send some ethers. For that, we send an object with a value key. And so when you send ether on the blockchain, you don't specify directly one ether directly, what you specify is usually a big number that this is in a unit called Wei. So that's a very elementary unit of ether. One ether equal 10 power 18 Wei. Okay, so it's not really convenient to directly code with Wei, because usually people think in terms of ether. So for an easy conversion, we can use a utility function of ether called pass ether, and is going to convert a string into a Wei number. So here 1 2 3 1 2 3. Okay, pass ether, and that's it. So with this, we're going to get a transaction, but we need to wait because we need to wait for this transaction to be processed by miners, or also called validators. Usually it takes about 12 to 15 seconds. So now we have sent the transaction, and we want to wait for when the moment is. So with the first line is just wait that the transaction is sent. But once it has been sent, that's it. It doesn't mean this is mine at this stage. It just means it has been sent. So to wait for the mining, you need another await. And now this is going to be transaction wait. Okay. And after that, you know what? We're going to get some feedback. So we're going to define a state. Payment complete, reload to see the private post. Okay. Otherwise, if there was an error, the payment failed. Please try again later. Okay. And what else? We also need the feedback when we start the transaction so that the user sees something, because the problem is that the user is going to click on validate, then they won't see anything for a long time. So they will, for a long time, it can be 10, 15 seconds, but it's long enough so that they think there is a problem. So we need to show them something. Okay, so now let's define this state. Set feedback, set feedback, and originally this is empty. Okay, and then we need to show it somewhere. So just below here, let's show it. Is there any feedback? Yes. So if there's no feedback, we show nothing. Otherwise, oops. There is something, then let's show an alert. Right. And just display the feedback. Okay. So with this, let's see what we have in the front end. So no, here. Okay, connect. Crypto Onlyfans, sign. So we have a okay, so here, so I'm connected on Metamask, I'm connected to our local network. So for that, what I did is I clicked on add network, here, add network manually. And then, so I gave it a name. For the new RPC URL, that's basically HTTP localhost 8545. The chain ID, that's something you can find in the log of, let me see. You can find it in the log of Envol. So if you go back up, you see all those info. Chain ID, you find it here. Okay, put the chain ID here, you click on save, and then you will see it in your Metamask. Then you select it, you select this network, which I've done. And also I've imported one of the address of Envol. So how I did this is basically you click on add account here, import account, and for the private key, you put here once again in the log of Envol, you're gonna see it. So the private key I already showed you before where it was. Yeah, I just put one of them. So I put the second one here, 0x59. So that's gonna match the second address, 0x70. And once you've done that, you can see this address here, 0x70, with a lot of ethers. Of course, I don't have this ether. This is just on the local mainnet, so this is some fake ether. But with this, we will be able to interact with our smart contract. We can pay now for transactions. And another thing you need to do is when you start a new network, when you run the network again, is you go into settings, you go into advanced, and you click on clear activity tab data. It's going to reset something called a nonce. So that's an integer that is incremented after each transaction. And for the mainnet, you never need to do this. You shouldn't never do this for any address on mainnet. But for local blockchain, basically you need to do this for every time you restart the blockchain. So let's do clear here, and it's going to reset everything. Okay, so now let's try again, connect. Okay, so was not happy. So we're going to do some commenting here and see from which moment. Okay, so I'm pretty sure this is this line. Let me see if it's not happy from this line. So now we're fine. Okay, what if I do this? Let's try. Maybe one of the address is empty. That's possible. So console log. Let me see, creator address. And console log signer address. Okay, so creator address. Okay, that's because that's so this is basically the same address. That why would it pose problem? I don't think. Let me try another one, but I don't think that this matters at all. But let me try. So let me see. right? So now let's try again with, for example, this one. So that's Angel, right? So the first one, let me go back. First address, the creator address is correct, 0x80. The second address, signer address, 0x70 is correct. So create, I think do we miss the signer? No, there's the signer already. What is missing? Creator address is correct. Signer address is correct. Let me see if we have here. We should see a log here, because if we don't see anything, that's not normal. Let me see. We don't even see it here. All right, so we will need to figure out why this line is not working. Let's try catch here. Creator address, signer address. Let me see. I've never, operation get ENS address. I've never seen. I don't know why they do this. The address that you use might be invalid. Okay. What about the address of the smart contract? So contract.json.address. Is it valid or not? So first one, address of the contract, then creator, then signer. Okay, 0xFB. Do we miss one digit? 0x, okay, 70, and it's end with C8. So let me see. The end with C8, yes. What about the other one? A0, and it ends with 20. So let me see. A0, and it ends with 20. Yes. And finally, for the blockchain, broadcast, it's possible. Maybe I missed one digit. AA3 and I missed one. Okay. This is difficult error to find, but we find it. Okay, so let's close this. Let's go to creators.contract.json. Let's go up. All right, now I should be okay. So let's try again. Okay, so now we made some progress, but there is still something. So Metamask RPC revert data. So at least now the contract is correct. Missing revert data. I supplied the wrong contract address. Okay, so why do we have this thing? Let's try to reset again. That I'm trying to think. Why? Trying to think what's wrong here. Okay, you know what? Let's just redeploy everything. So clear tab data. Okay, let's envol. So let's reset it. Okay, now let's deploy the contract again. Okay, and I think the address is gonna be the same. 0x f5 5faa3 5f yeah, this is the same, so that's fine. Okay, let's reset again. All right, and unfortunately, we still have this. We still have this error. So why does this? Let me see. I was working just before. But are we even going here? Here? Huh. Members. Okay, let's see. Do we have members? Do we have this function in the, let's see, members function members address? So here we have a member function where we provide two address and output and the output is the output is Boolean, and that's correct. What about the? I'm paranoid now. Let's get back in the smart contract and members. Yeah, it's public, an address, Boolean value. So yeah, so it should be perfectly fine. So that's the problem when you develop with Metamask. It tends to be quite unreliable. Sometimes you have those problems, and sometimes it works, sometimes it doesn't work. That's super annoying. And what about here? Do we even have anything here or not? I don't think so. Missing I don't know why it's doing this really. So let's move on. Let's just hope that after it's not gonna do the same thing, but I'm skeptical, unfortunately. All right. All right, so yeah, we're going to cheat for now, okay? And we're just gonna set is pet member. For now, it's gonna be false. Okay, so let's keep going. And what we need to do after, basically, is to join. So let's create a function when we want to join. So here we have the button join, the function join. So we already have the function when we want to join. So let me see this. This function seems right to me, but because we had this issue before, I'm afraid we're gonna have this issue again. Transfer pending. Okay, so here account 5, that's the correct one. And we are going to execute a transaction on 0x5b, FB here. Okay, so let's confirm. And unfortunately, the payment failed again. All right, so what is the issue here? It's a little bit difficult to know. Okay, let's move on. Let's not stay stuck. Okay, so now let's try to get the private post. So how are we going to do this? So if we're gonna use another use effect here, so let's say that we have the signature, okay, and an is-pet member. So every time those either of these two is updated, this function is going to be executed. And if we have the signature and is-pet member, then we want to show the private messages. So how are we going to do this signature here? How are we going to do this? Basically, we're going to create a new function called get private post. We're going to pass it our address and also the signature. Okay, so signer, let me see, signer address, signature, and here set private post. Okay, so let's go up and let's define this. Private post. Actually, we need 3 things. We need several things. So first is we need the creator, then the user, then the signature. And we're going to use the fetch function. So we're going to hit the backend here. Okay, so let's copy paste this. It's not going to be exactly the same thing. So we're going to create a new endpoint called post. And here, this is going to be the address of the creator. And we are going to pass our signature and our address with header. So, you know, it's the equivalent of API key, basically. So the signature. Okay. And let's get the answer. And let's transform this into a JSON. Right. And then we're going to put this in a key called data. Okay. Creator, what else? Oh, no, here, user. Okay. Here we are missing the creator. So I think it's creator address, right? Creator address. Okay. And so now we need to create a new endpoint where we're going to check the signature. So let's go there. Creators. Let me see. Where are we going to create this post? Okay, let's. So, new folder. Post. Okay. New folder. Address. Right, and let's create a new route inside. Okay. So let's call this endpoint. This is a get. Okay, so export async function get. So we won't care about the request parameter, but we care about the params. And first we're going to read you're going to read off a local file. So let's import the FS module of Node.js. Okay. Then we're going to import the headers because we're gonna need to read some value from the header, the signature. And we also need to import ethers because we need to read from the blockchain. All right, so now let's first get the post. And okay, so we're gonna get the post. By the way, we need to create this file because we don't have it. So let's do this. Okay, so I actually prepared some data already. Let me find this. Okay, so here let's change the author because I changed the address. So creators, now this is this new address. Okay, so we have an array with all the posts here. So each author has 3 posts. Okay, so let's go back to the API endpoint. So we get our post, and what do we do next? So we are going to filter the posts that are relevant. Post data filter. And we want the post author to match the address that we pass in the parameter. Okay. Then we're gonna read from the headers. So for that, we need to use the headers function of NextJS. And first, we're gonna get the user. Second, we're going to get the signature. So all right, then we covered, let me see, we covered address. So we're going to use a special function of Ether called verify message, and it's going to extract the address that was used to send a message. So then we can compare this signature with what we got, the signature that the user claimed to have. So first, the message. What is this message? Is this one, crypto only fan? So sign the same message. And now we need this recover address. It needs to be the same as who the user claimed to be. And there's no way to lie here. Okay, so if that's the case, then we're going to answer, we're going to return the post. Okay, with a status of 200. Otherwise, else we're going to answer nothing. So actually, we should do 401 here, not authorized. But then we have to do a try catch in the front end to deal with this. So I'm just a little bit lazy here. Just want to return an empty array. Okay, so let me pause here and see what we have in the chat. In a real world scenario, let's say you really build this out, would you end up covering the gas fee for when they sign up? Well, if I have some VC money, yes. Otherwise, no. But basically, you have to use a blockchain where they don't spend a lot of money. So probably it wouldn't be Ethereum. It would be a L2 like Arbitrum or Polygon or something else. But it will still be based on the blockchain technology. Okay, so asking in real world situation, will dApp normally cache it, require you to reconnect on refreshness? So basically for the signature, you could store it client side in the browser storage. And so when you load the app, then you check if they already have a signature there. And if that's the case, then and you will need to give it a special key so that you know this is your data. But yeah, this is how we do it. Sensi, nice work. Thanks, man. So Danshi Gaming said, try clearing your Foundry cache and then removing the wallet you added from clearing your Foundry cache, then removing the wallets you added from Anvil and read them. Okay. Interesting. So yeah, I might try this actually. Thanks for. Yeah, you have all those problem when you interact with Remix. This is with MetaMask is so annoying. Anyway, so actually here, if we go back to my code, you will realize that there's a problem. So we verify the message, which means that we identify the user, which means we are sure that this person is really who they claim to be. But then we are not sure if they have paid, right? So now we need to check that. And actually in my original code, I did not plan this part. So we need to do some live research here. But at least here we won't be bothered by by MetaMask. So let me see. We need to create a connection to Envel, and then what we need to do is basically check call members to see if the user is paid user, and if yes, return post. Okay, so first create a connection to Envel. Let me see how this is going to work. So I think this is going to be with a JSON RPC provider, probably. So let me see. Ethers read data from Envel. Okay, Ethers connect to local node. All right, so yeah, this is what I thought. Ethers provider JSON RPC. Yeah, I think it's this one. Yeah, so let me see. Right, providers, JSON RPC, and then this will be HTTP, localhost 8545. Okay. And after that, let me copy some code that we already have. So here. Right, so let's also import contract.json. Okay. So JSON RPC provider. Then, okay, so here I'm a little bit bothered because I don't care about a signer. I just want to read data, so I shouldn't need a signer. I'm not sure if it's possible to do it without a signer. And then what we would do is basically is pet member, and so we would do contract dot members, and would pass first the array of the creator. So where do we have this? This is in the params, I think. Params address, that's the creator. Then the user would be user, okay. And basically here what we would do is we add the condition and is pet member. Okay, but here that's this part that bother me because do I wanna, let me see. Can I just pass a provider here? Because I don't care about signing. Basically, I don't need to sign message. I don't need to send transaction. I just need to read. So I shouldn't need a signer. Okay, so let's try this. Let's go back here. And here we're gonna get the private post, but we don't. So pet member, basically we're going to cheat. We're gonna say, yeah, we are set is a pet member to true. Okay, we are cheating. And let me see. And then we need to display this. So how are we going to do this? Okay. So if we have some private post here, otherwise we don't show anything, but if we have some private post, so let's show it, private post. Let's display them in the list. So here the class of bootstrap list group. Okay, here class name equal list group item. Okay, actually we need to iterate through the private post here. So private post map post in, for each iteration we output a list element. Okay, and inside we need a key as well, because otherwise React is going to complain. So fortunately we have an ID in each post, and then the post content. Okay, so now we can display the private post if we have them. Okay, so now let me see. Private post is not defined. Yeah, it's normal. It's normal. So okay. Right, so now let's click on connect. Okay, so route cannot resolve contract.json. Okay, so we need to modify this. So let me see. 1, 2, 3. Okay, we need one more. Let's go back here. 1, 2, 3. Okay, let's try again. Okay, so next, what's the problem? Okay, so let's see this, the output, the argument. UTT-8. Okay, so UTF-8. Okay, so let's try again. Another error. Okay. Cannot read property of undefined. Okay, so here's because in v6 Ethers doesn't have dot providers anymore. It's directly on Ethers itself. Okay, so okay, next error. So what is it this time? Class constructor JSON provider cannot be invoked without new. No problem. I can give you a new if you like it. Doesn't cost anything. Okay, so now we can see the private post, but I'm guessing, so there was no error. So I'm guessing is pet member. Yeah, so is pet member is going to be false because the transaction failed. We have this problem with Metamask. So let's console log this thing, is pet member. But I'm glad that we didn't have an issue with the connection to the blockchain. So that's good to know. It seems like this is working at least. Then let's check out the recovered address and finally compare these to the user, so they should be the same. Okay, so let's try again. All right, so yeah, ESPED member, this is not true. And then, but the recovered address and the user, they are the same, which means that the signature system is working. That's awesome. So what we're going to do is we will cheat. We have no choice. We will cheat. Is pet member is true. I want my Onlyfans. Sign. And now little problem here. Private post is not a function. Why is that, my friend? So console log of post, and let's see. Should have something. Oh, okay. I think that's because let me see. Okay. Here, that's because we are missing this. Okay, so let's try again. Okay, cool. So now we can see the private post of Angel. Amazing. Okay, so this is kind of semi-working. Yeah, we are still blocked by the issue on the MetaMask side. So as someone suggested, maybe if I reset everything, reset my cache, etc., we can fix it. But I've already tried. I don't want to waste more time on this because we still have one feature to implement, and it's been a while already. It's been almost 3 hours. So we need to finish this stream at some point. So here, the last thing I want to show you is, because basically this little problem with MetaMask, that's nothing really. The code actually works, okay? So there is no need to waste time on that. But now the next thing I want to show you is the administration for a creator. So let's say I'm a creator, and how can I update my data? And we can also control this with a signature, basically. So we're going to do it. So we're gonna create a new folder called admin, and inside admin we're gonna have a page. Okay. And so use client because this is going to be on the client side. Export default function admin. Okay, params. So we are going to return some basic HTML. All right, so let me copy paste it from another place as usual. So from here, for example, okay, so let's rearrange this to make it look nice. All right, let's close the div. Let's close everything. Okay, cool. So what else so now we're gonna call this admin panel for creators, CK, and okay, admin panel for creators, perfect. Next, as usual, we're gonna ask people to sign. So once again, we can copy this. And by the way, when you see that you do a lot of copy pasting from other components, that's a sign that you need to refactor this and extract those snippets into their own component. But since this is a tutorial, we're just doing it the dirty way. Okay, so here, let me see after. Okay, so let's create a connect. Yeah, we're gonna create a connect function. So very similar to what we have before. So let's steal the code. Right. Okay, so we need a signature. Yeah, we need a signature. So let's copy paste. Yeah, we need a signer also. So let's copy paste these two, and we're gonna have a feedback also. So let's copy paste all of that. Okay, so let's remove his ped members, not relevant. Okay, so now we're gonna sign exactly the same way we did it for the regular user. Then what else we going to have? So when the signer and when the signature, when we have these two things after we connect, basically we want to load the data relevant to this creator. So for that, we're gonna use effect. So let's import it from React. Here. And we wait until the signature and the signer have changed. If the signer and the signature are not undefined, then we initialize this, we run this function. So what we're gonna have inside is we're gonna get the data of a creator. I'm going to set the description. Okay. Basically, we're going to have a state where we have the description of the creator, and we're going to show it because that's basically the only thing that we can change. All the rest, the address, you don't change it. Use state. And what's really cool is that there is no registration procedure. It's like you just, as anybody can update their data as a creator. You just go to the same URL/admin. If there is already something, well, you would just update what is already there. And if there is nothing, well, it will just be the first time. But it's super easy. Okay, so set description. And now I get creator. We need to create this function, but let me see. Do we have this endpoint or not? So we have an endpoint for API creators address. Let me see. So this one is going to find a single creator. So we already have it, which means we already have the code to fetch it, I think. Yeah, get creator. So yeah, again, we should extract this code into its own file. So admin page here. Let's get our code like this. Okay. Yes. Oh, we need the message to sign because let me find this. All right. Okay, and next, so once we have this data, so first of all, once we have this data, we should populate. So we're going to have a form below, and we're going to populate this form with the data we already have. So now below the signature, if we have, well, first of all, below the signature, if we have a signature and a description, we are going to output a form. And inside the form, we're gonna show a couple of stuff. So first, we're gonna show the address. Okay, I'm a little bit lazy here, so just bear with me, but just going to do some copy paste. Hey, I have the right to be lazy, and it's been 3 hours. So, okay, so here we're gonna have an input for address, but we're going to disable it because we just want to show what is the current address. Then we're gonna have a field for description. This one, we will be able to change it. All right, so here, this is a text area, and the value, basically the value will be read from the description state. And when we change something, we're going to update the description right away. Okay. And finally, we're gonna have a button to update all those value. Okay. When we click here, we're gonna trigger the update function that we need to create. So first, we prevent the form from being sent. Okay. And then we're gonna do all the thing, but first I want to make sure that we have the data here. So, all right, so I'm sure we're gonna have a couple of use state is not defined. Easy, easy. Then use effect is not defined. What? Use effect. Okay. So now connect. Error. Ethers is not defined. Okay. So we can fix this. Import. Okay. So what's next? Now we need to sign. Cool. Cannot read property, page 29. Okay, so what's the issue here? Creator, so what did he say already? Cannot read properties of undefined. So here the creator, we're not getting anything from why are we not getting anything? Because we don't hey, that's strange. Why are we not getting anything? Console log the creator here. Okay, so let me see. Undefined. Okay, so we have no creator back. That's maybe because maybe that's my fault actually. That's entirely my fault. Because let me see how we could fix it. Okay, if we import, okay, let's say that now we are one of the creators. So for example, this address, but we need the private key. So let's go there to envel. What about, I was, which one? 0xA0E. This is the last one. So let's check out the last private key. Okay, this one. Add account. So import account, private keys here. Boom. What else? Right, why you're struggling so much to import a private key, my friend? Should be easy. What's wrong with you? I hope it's not going to bother us. Why? Okay, so not, let's connect it. What's your problem? You know what? It's just really bothering me. Let's just take the old one and we're just going to change our file. So here, this address is a creator because I've decided it. Okay, so now we're gonna see some data. Okay, cool. So now you see, we can see our data, the address and the description. And so the goal is that when we update it, we click on update, it update on the backend. So we need to create another API route for this. And so let's do this. Admin. New folder, admin, and then what's inside admin, we're gonna have a route. Okay, and so let's import the file system because we're gonna read our JSON file. Then we also need, we're gonna need the header. We're also going to need Ether to verify the signature. And finally, we're going to need the message to sign. So this one. Okay, so now let's export the endpoint. We're going to need the request object. First, let's read the header. Next, let's get the user. Actually, we already have a bit of this code elsewhere, right? So, you know what? Let's check it. Where is it? It's in post, I think, here. Yes, so let's get all of that because this is going to be the same thing. Okay, so we get the user, get the signature or recovered signature, and if the recovered address is different from the user, that means they are not who they claim to be because they don't give us the correct signature. So we're going to tell them it's forbidden. Forbidden. Then if it's not otherwise, it means that it matches. So in this case, let's read the creator file. Okay, creators.json, then UTF-8. Okay, and then we're going to pass it because we want to turn it into a JSON. Do we need to do this? No, I don't think so. I think when you import a JSON, it's already passed. So I don't think you. No, because you are reading. You know, okay. It actually, I think I'm making my life more difficult here. When you read it, you actually don't need to. Let me see. What's the difference if we just import it? If we just import the JSON with an import statement here, what's the difference? Because it's more simple to write it, but I think the difference is that the old value of the JSON is going to be cached. So when the endpoint is going to be called again, then you're going to read from an old value. So that's why I think this is not right. Yeah. So we do need to pass this. So creators called JSON.pass in. Right, let's do it. Now let's get the parameter in the body. So weight. Okay, so now we're going to update here. So line 19, basically we're getting the parameter from the front end. So the new description, basically body.description, and then we're going to write file sync to this file, right? So now we need to stringify the creator's JSON. Encoding is UTF-8. Yeah, so now we update the file, and the response is that everything is fine. Okay, so now it seems like this is going to work. So now we need to connect it on the front end and we'll be done. We're almost there. So let's go back to the front end. And first of all, let's get some feedback. So update pending and update finished. Okay, so now I'm going to be lazy. I'm going to copy paste the feedback part. Okay, so here, if you have some feedback, then you show it to the user. Very simple. And back in update, so we need to call our endpoint. Hey, let's do some copy pasting here. Let's save some time. So the endpoint is API/admin, and there's no address. And now we are going to post, so it's not a get. It's a post, like whenever you modify data, it should be a post. And we're gonna need some we need some the header here. So let me see. Okay. So the header, no, sorry. We're wrong place. Wrong place here. So the header will be the signature and the signer address that is stored in the state. And then the body, you can do stringify what the a JSON object with the description. And what else? Accept. I think we are missing something here. So accept means like we want some JSON back, but we also need to say that we're going to provide some fetch post JSON. Let me see. Content type. This is what we need. Okay. Content type, right? And this one is between quotes because in JavaScript you cannot do this. Basically, it doesn't tolerate name with a hyphen, a key name with hyphen. Okay, so and here should be async. What else? Then we should get the JSON back. well, I don't think we're going to do anything with this, right? Because update, let me see where update is connected. So yeah, we're not going to do anything with this. So we just want the feedback here to stop, to change. Okay. Whew. So now let's see. Connect. Okay. Test, update. Request with getHead cannot have a body. Yes, but okay. Method shouldn't be in header. Method should be at this level. Okay. Connect. Here. Update finished. Cool. So now if we reload, do we see here? Yes, we can see it. And what about the JSON file? Creators.json. So here, we can see it. Awesome, so it's working. So now we have our admin panel that is secure with our signature system. There is no need for registration. It just works like this very simply. So yeah, that's pretty much everything I wanted to show you. So I'm sorry for the problem we had with Metamask, but the demo I showed you at the beginning of the stream was working. So the code is working. It's just a little problem with Metamask. So now, how could you do this app even better, right? So good question. So first of all, styling. So you can see here the styling of Onlyfans is a little bit better. So for the list of posts, you could try to make it match more closely what you have here. Then on the real Onlyfans, so you have text, but you also have pictures. So you can also add the ability to upload picture in the app. Then what else you can do? You can what else you can do for the smart contract? So right now everybody is paying exactly the same thing, but maybe that each creator can decide how much they want to pay. So that's something else like that you could do. You could do payment that accept different things, so not just Ether, but also ERC20 token, and again based on the preference of each creator. You could add a subscription system, but that would be significantly more difficult, clearly. What else can you do to improve our app? Oh yeah, so right now we're storing all the data is on the JSON file, so it would be better if we used it would be way better if we use a database. Okay, so yeah, like something like Superbase. It wouldn't be too difficult to in the code, the modification, it wouldn't be too much to do this. What else you could do to store if you added some image? So the most simple way to store image is on your server, but that's completely not scalable. So you will need to use a service like AWS S3, for example. Could also be done on how do you say? Could also be done on IPFS. So even though it's public, if people don't know the URL, then it's impossible to find those images. What else? What else you could do? Yeah, I mean that would be a lot already. But yeah, that was like my longest stream ever. Like I think so more than 3 hours. So I still see that some people are still here. So thanks, guys. That's amazing. Let me see who is still here. Maybe Desli Makule saying, this would be an interesting project to talk about in an interview. I mean, you're laughing, but it's better to be the guy who did OnlyFans than to be the guy who just did a to-do app, clearly. All right, guys. So with this being said, Shamrun just joined. Oh, man. Sorry, but that's the end, dude. But close. Nice stream. I only understood a little bit because I'm not a programmer. Okay, man. I mean, it's a nice effort to try to follow. So, yeah, some people always ask me about the source code. So as I mentioned during the couple of previous stream, I may open a membership on Eat the Blocks where you get access to the source code. So I'm gonna keep you posted if I decide to do this. Okay, thanks everybody for following. We're going to stop here. Have a nice day. Bye.